Here's pre-calc. This is problem 6-53. This problem is about Darren and Christina, and they're both running around a circular track, but Darren is on the inside part of the track and Christina is on the outside. So his radius is only 40, but hers is 44. They're running with the same angular velocity, so they're both going around evenly. It's just that she's covering more ground as they go around. And so they told us that her rate, Christina's rate, is 11 feet per second. And they want to know what is Darren's rate. How fast is Darren going? So your book did it a different way than I did, and it's a lot nicer, but I don't really understand it. I'm not sure. Well, I mean, I understand it, but I'm not sure if you would automatically think of this. But so our book says if they're running with the same angular velocity, then the ratio of Christina's linear rate to distance traveled is the same as the ratio of Darren's linear rate to distance traveled. So if we could just find the distances, this is Christina's distance. So distance for one time around would be 2 pi r, and her radius, since she's on the outside track, is 44. His radius is 40. So 2 pi r, so that's the circumference of her circle that she's running around. So 11 is to 2 pi times 44 as x is to 2 pi times 40. It kind of makes sense to me. If you do cross products, you have 11 times 2 pi times 40 divided by 2 pi times 44, and that's going to be equal to x. And so that comes out perfectly to 10. So that's nice. I thought of it a different way before I looked up in the answer key. The way I did it, you might not like it as much, but I thought of distance equals rate times time. So I thought of this as her rate, and we're trying to find her time. I wanted to find her time so that I could fill in all the things that I don't know, all the unknowns. So I got Christina's time because I know each of their distances. So Darren, he's on the outside track or inside track, so his distance is 80 pi because it's 2 pi r, 2 times pi times r. That's his distance. That's Darren's distance. And then Christina's distance is 88 pi. So I know I can get Christina's time by, I know that rate is distance divided by time, and time is distance divided by rate. So I can take her distance and divide by her rate. Where's Christina? There she is. So I took her distance and divided by her rate because we had both of those. And I found out that it took Christina 25.13 seconds to go once around. Well, since they're both going around like even with each other, they have the same angular velocity, that's going to also be Darren's time. So Darren, I just filled that in for Darren, so that's 25.13 seconds. And then I can go, the rate of Darren is distance over time, so I got 80 pi over the time that I just found, and that ends up being approximately, not perfectly, well, I did some rounding, it turns out to be about 10 also. So there's another way to think of it.